Okay, center of mass.
See this? Yeah.
Answer for me.
Just because it's so.
Okay, now that I bummed all of you out. Not these. Well, I think I put a few more on there, but they're white.
How does this affect this class? Cause how does that affect this class? Cause
You still get the notes you've always been able to make,
yeah,
but it's like if you forget to print them out and you're like, oh, they're on my iPad. Even though I could check them before and see that they were handwritten and properly prepared, you just can't have them on an electronic device anymore. You have to make sure you have them hard copy in your hand. And then all electronic devices will be put away.
so really nothing changes, just on paper still?
Yeah,
Okay.
and just before, people would have like phones and stuff sitting on the top.
Oh, okay.
We're just gonna make sure all that's put away. Also.
Yeah.
You have to have a calculator.
Okay.
Ah.
I know there's still too many people who rely on the phone calculator. Quite frankly, that's just not gonna get you through science. You need a calculator with more functionality.
Bring like a $2 Casio or whatever.
Yeah.
It smells like old last name.
You took it back nice.
Okay, so
So now you wanna let that?
look, we got that done. You guys can go do whatever tonight to forget you feel bad. I'm sure within an hour you all feel fine.
Why do we feel bad? I don't feel bad.
I don't know, because I feel bad. I don't like having to have. conversations.
I haven't done something about that.
We like you, so I don't care. So do on the other hand.
I'm not accusing anybody. You're saying this came from like way above me.
Is it like happening to all the professors or just like certain ones of you guys?
It's kind of a widespread issue across this entire building.
Just the math and science building though.
Well, business.
Business?
Math, science and
What's
physics.
to those kids online anyways?
I think it's probably gonna go to.
Oh, and business.
Yeah, so. I'm gonna make sure all of you are in a position that when this is finally dealt with, it doesn't hit any of you.
Are they gonna come down on specific kids?
Very likely, yes.
They're gonna what?
Find out.
It's going to be dealt with.
Oh,
I just don't want it to be any of you,
I'm okay.
okay?
Don't worry, I write my cheat notes with my hand.
You know what? I'll accept that. That's hard copies right there.
I mean.
Clearly hand wrote though. Well, it's like in your hand in the printer going, come on, out.
Because he's new.
AI and applications that will solve things.
What application is this? I'm quite curious.
Snapchat AI.
Boy,
Doesn't solve the entire
I mean,
exam.
how many of you remember telling me telling you to be careful with chat?
Yeah.
Remember why?
Teachers.
Just fake answer.
Honestly, the only reason why I still pay for Jig is for my.
Even on there as experts, and they put in the wrong solutions.
Chegg is so expensive though.
Uh-huh.
It's crazy expensive.
For something that about half the time is going to give you the wrong solution.
Need it.
So. Yeah. Okay, no more unhappiness.
It was really good though. Organic.
Okay, so how do we start finding the center of mass? We have three masses, they're gonna act as a single system. We see that we made that little correction, mass 1 equals mass 2 is 1 kilogram, mass 3 is 4 kilograms. Find the location or the center of mass of the three objects. And so the first thing you take account of is that, for example, mass 1, the 1, mass 2, 2, 3, and then. Yeah.
It was also 90%.
Cheating off someone else, like if I was looking at someone's stats, is that now used as mild cheating? Like, to me now that feels almost more ethical.
That's just academic cheating. It's like from the table.
I feel like that, you just get a 0 on the test but like not get expelled.
I'm just using someone else's knowledge and not AI. Like, I can still be wrong, so it's like. I'm using wrong. Yeah, you're making a big
Double jeopardy at that point then?
right? Like, doesn't that almost feel like less, like, it's not as bad?
Yeah, I get what you're saying.
Let me put it to you this, let me put it to you this way.
It's so disappointing. Yeah.
Going to show my
This is why things end up in safety manuals, where you're like, why did you have to tell me that? Because someone did it.
mask.
But, no, that's not any less ethical. I really do try to make class something enjoyable for students. I just want to make sure that no one ever mistakes kindness for weakness. Because, yeah, you all mean a whole lot to me. However, if I catch you cheating, I will fail you so fast your head will spin. Okay?
Yeah, do it a little slower than that.
A little.
Whole deal, trust me.
So you're saying you'd be equally mad as if you like caught me like looking at Jada Smith
Yes.
versus like using it?
Yes.
Why did you not think? his
So
answer
then
was
just
yes?
use AI.
Why did you not think his answer would be yes? Because like. to
If
me,
you're gonna
that's
get the
like-
same punishment for looking off your neighbor as using AI, like, just use AI.
Oh, it's cheating.
Let's just not risk it altogether.
Wait, it's not just Coyle that's getting the emails from the VP.
What? No, the professor. Not even that, like.
It's
I would. love
math
to
and
do
science
that.
and business, he said.
Yeah, philosophy in the old admin buildings also, those professors also.
Let's just not risk it, okay?
I don't wanna ask.
A lot of you have ambitions for your futures. That is the kind of thing that will 100% put a stop to it. Because like, for example, if you get caught cheating here, that will go up to like UNMC or wherever, you won't be going to school there. It's just, don't risk it.
No, my issue is
Now,
I actually
what do
think
you
that
think
was
is
right.
more serious though? Or HIPAA?
It's so stupid.
I've gotten into an ethical standpoint on this.
One of them is a school policy, one of them is a federal policy, one of them will end your future, one of them will put you in prison.
Yeah.
So I think you have a problem.
In the class for.
Well,
You're talking about.
this is the thing, and then I asked if you thought, like, looking off your neighbor's paper versus AI is, which one's worse? He said both are bad. Stop asking you.
I know, that.
This is like wondering, cause like, I don't know. No more, no more.
You don't have to respond.
This weekend, I'm gonna take a handful of Tylenol, I won't remember anything by Monday.
Okay, I'm sorry that I asked you.
Just not a question I expected.
I have an hour to make
I tried to prepare for what you guys might say in class, but that question, not my repertoire.
I'm sorry, did you get two minutes put in? They put
Okay.
on it, no.
Center of mass.
They put it in four.
Now,
Calling it Tylenol.
we're gonna, so, okay, we said yesterday we're going to do center of mass in each dimension, okay? So what we're looking for is a set of coordinates where the center of mass is at. We're not looking for like a single number. We're looking for coordinates. So if you imagine this is a single unit acting together. What we're gonna start with, let's just center of mass of X. So we start there. This is gonna translate into. So this is where you would get to, and then you would start plugging numbers in. So what do we have? We have 1 kilogram, so that's 1. It's a centimeter. We're gonna have 1 kilogram. And that's 2. And it is going to be 3 centimeters. And then for mass 3. 4 kilograms. 3 centimeters. And then the denominator. Kilogram. Kilogram. 4 kilograms. Okay, so we get your calculator out and tell me what the X value is for the center of mass. 2.5? Yeah, it's pretty close to there. Might be more like 2.6. Yeah, it's pretty close to there. What you're gonna have 1 plus 3 plus 12. That's 16 divided by 6.
Like, when would be appropriate time to take a, say, 10-month-old?
Well, if you're with the 10-month-old, it's really up to the mother. You have to keep it, like, I would keep in mind bedtimes and, stuff like that. I think for young kids anymore,
I think
trunk or
it's like
treats are
5.
safer. But
Yeah, well, trunk or treat, that's already happened. But like 5, right?
Five is probably pretty decent, especially if you have a little kid and you show up
We're
around.
expecting
5.
people like 4.
I like 4.
Yeah,
think
that's what they did last
if
year.
you have like a little kid,
We
he's
have
going to
full goodie
school that you
bags.
know.
Not just like candy, like full big goodie bags.
Somewhere around 2.6, okay?
You guys just say trick or treat and we'll get.
But in the center of mass for Y,
I'm saving it for.
You should so make this be in.
You have to hold them.
If you dress up as
it'll be the same thing just with our Y coordinates.
Next series.
I would
So this is what?
expect
Kilogram. Centimeter. Kilogram. Oh, shoot, hang on.
Scrub top out of the
This
lab.
is supposed to be 2. There we go.
The female model so that no one can see. her.
Yeah, because it's at 2, 3. I was looking at 3.
Everyone, I have a question. Can you let me into the dry lab after this class so I can get my scrub top?
Which lab?
The anatomy lab, right?
I'll try. I don't know if I have keys for that one.
We put my scrub top on the little model last night, so the little kids didn't have to look at her booty.
And so then your Y coordinate, you're gonna end up at about 1.33 centimeters. So then your center of mass,
You know what? It's stuck in my head.
It says I look like.
you're gonna be at 2.5 centimeters.
He's about to be tight, that's why I only.
3 centimeters. So commonly center of mass calculations aren't that difficult.
That looks pretty difficult.
Is it only difficult if you don't pay attention?
Yes.
Oh.
Fuck, my face, I took this slide.
Now that's finding the center of mass. Now we can start talking about the motion of the center of mass. And as my yearly tradition, I have to put a Mihoy Manoi meme.
What's up, what's that?
Lee doesn't even.
Doodle Bob. You don't know Doodle Bob? And so when he goes, me,
Yeah, but he loves SpongeBob.
I was allowed to watch SpongeBob.
Okay, so
Yeah, I forgot.
you notice that the motion, the velocity of the center of mass is very similar to the actual center of mass equation. And then the momentum of the center of mass is going to be the sum of all your masses multiplied by the velocity of the center of mass.
Go there.
Okay? Yeah, let's kind of talk about that.
Oh, I was gonna say, do like a picture of me.
This time we're going to use a mass that's just kind of an amorphous blob.
Mhm.
Because we need to kind of think of this as a mass that can take pretty much any shape. Okay? Every mass then could be thought of as consisting a bunch of individual little masses. Okay, and then we'll say that maybe center of mass is somewhere around here. Where you have, I don't know, there's one, there's two, there's three, so on and so forth. Until you get to some mass I. As we talked about, each one of these is going to be drawn out by a position vector. Okay, so now what we also need to think about let's say each one of these can be seen as having its own velocity. So that means that the center of mass also has a velocity. Because if each one of the individual particles is moving, the center of mass is moving. So we're going to start taking account of a couple of things we know. Well, we know for a fact that the velocity of particle I is going to be remember that. So that also means that if we change this around to solve for delta R,
Just so cute sheep.
this means that we can also extrapolate that
Some kids were crying because they were so cool. I felt so
and
bad.
again, you see that I'm using a common delta T. Delta T is not, and why can I use the same delta T for every single particle in that object? It's one system. It's a solid object. It's a system. They're all going to be moving together. So as they move, they all experience the same delta T. Okay, well, we know we go back to our generalized definition of center of mass. Okay, and then we can substitute in for delta R. Okay, so we can do that, and we know that this is going to equal this velocity of the center of mass, delta t. So then let's divide through by delta t. So that's going to cross out the two delta t's. And so then what we end up with is the theorem that we just saw, that the velocity of your center of mass so again, it's very, very similar to the center of mass equation. So they're going to have the same format. It's just one, you're exchanging position for velocity. Now, let's take this a bit further. We can say, well, okay, we're just going to multiply through by the sum of all the masses. What do I have on the left side there? Mass times velocity. Mass times acceleration is force. Mass times velocity is.
Density.
Nope. In here, I thought celestial beings are supposed to know everything.
That's what my Halo,
Okay,
taking the vote of me.
that's the quote. Come on, mass times velocity. The temporal derivative of velocity is acceleration.
See it again? Oh, wait, that's.
Momentum. Mass times velocity is momentum. Like the name of the chapter. And so what you see is then, when we take the sum of all of the momenta, so the momentum of each individual particle, we get the momentum of the entire system. Then we're going to sum together every mass in the system and multiply it by the singular velocity of the center of mass. And so now, just like we did before, you can break this apart. So let's say you wanted to work on momentum in component directions.
That's crazy.
So the velocity of the center of mass in the x direction.
So you could.
So you can break these apart component by component. Which I hope you can tell that we're working up to the point where you're going to have to do a two-dimensional momentum system. Specifically collisions. Now, we've been talking about systems where everything's been conserved, no external force. What happens when there's an external force applied to the system? What happens to the system? What if I told you that velocity is not constant?
It dies, the system dies.
The system can slow down.
Dies.
It dies, yeah. I mean, but if velocity is not constant, if I apply an external force, what happens to me?
Dies. You die.
Changing velocity.
Change in velocity means what is present? Acceleration. You have acceleration.
die.
So we can start real simply. So remember that our acceleration is the change of velocity over the change in time. So let's go ahead and take,
Move off. We like Twin Towers.
I'm gonna take the velocity of my center of mass divided by delta t, which means on this side,
18-3. Why do you have to keep slamming? I know it helps your ego, but. Doing lilac order. Yeah. Just slamming it at us. You're like, see the score right now?
so I'm just gonna add that delta t to each side.
No. No.
Now, the right side here, or the left side, what do we end up with? We end up with acceleration of the center of mass.
Oh, no.
And I'm gonna take this and multiply it through. There's gonna be my acceleration.
You don't plan.
Go show her mine.
Times this, multiplied by the sum of all those masses. On this side, it's going to leave.
I got all the good ones. Go what? Oh, wait, no, no. House, not the shack.
That's gonna leave, this, your mass times velocity over delta. Which,
With like 20 kids.
so we said the mass times velocity, that's gonna be the.
At the very beginning.
So then my question is, I have momentum over delta t. Which is what? Change in momentum over change in time is what? It is, it's because it's, remember, that's the second way we've learned to write Newton's second law. So that means
It's a pet house.
some of our forces are gonna equal some of our masses multiplied by the single acceleration of the center of mass of the system. And we can write the sum of all individual forces as just our generalized external force.
Even bad. I just gonna make even bad. I live even under the chair. I live in Florida.
No, don't
Okay.
read it. I don't want to hear it.
So this is how we really start to deal with a system moving where we judge it by the motion of its center of mass. Now,
I'm gonna need you to erase this.
see how close are we to it? So I have a lady having a mass of 55 kilograms walking on a raft. The raft has a mass of 100 kilograms.
Is 55 kilograms a lot?
Huh?
How much is that in pounds?
You can
Times it by like basically two,
basically what?
basically two
Um,
times to get to pounds.
So what, about
121.254. That's a tiny lady. Okay, never mind.
what is she 4 foot tall? I don't know.
Well,
But
let's just assume average height of a woman.
so she's 55 kilograms walking on this 100 kilogram mass at 141 meters per second relative to the raft. Raft, so then what happens, like, You've ever been on a boat on the water, you walk across it, what does the boat do? No, we're not that.
Are you sure it's not this?
No, I'm.
When I step on it.
It's on what?
Just
What does the boat do as you walk across it?
It goes like this.
It goes in the opposite direction.
It goes in the opposite direction. Your motion causes the boat to move, the raft to move that way as you're moving that way. The raft now is moving in the opposite direction at 0.5 meters per second. Suppose it takes her 3 seconds to walk from one end of the raft to the other. First off, how far does the lady walk relative to the water? Can you suss out what's happening? She's moving at 1.41 meters per second with relative to the raft. The raft is moving 0.5 meters per second in the other direction relative to the water. How far does she move in 3 seconds relative to the water?
I don't know, she's not Jesus, she can't walk on water.
You have to like subtract one to find like the relative
Right.
velocities.
You have to find her velocity relative to the water.
But she has to write the log.
Okay, so
And I said, a lot, stick horse.
velocity of the lady.
Stick horse.
So-
Could we basically just say that she's walking on water?
See what I'm talking.
Yes.
Oh my gosh, Jesus.
No, exactly, that's what I'm saying. You're gonna be like Jesus if we walk on a boat on the water. We're walking.
Yeah.
Be more like.
She's on raft. Velocity of the lady.
Okay, I got one. No, horse, stick horse, stick horse.
Velocity of the raft.
Horse.
Elizabeth X.
I got walking.
Now maybe we're six.
Walking everywhere.
So the velocity of the lady.
I don't know how to spell.
Meters per second. Velocity of the raft, 0.0 meters per second. Now the velocity. The lady with respect to the water. Is going to be.
Respect the water.
The velocity of the lady plus the velocity of the raft, which is gonna give us.
Don't you mean really funny?
So according to the water, she's actually moving at a negative 0.91 meters per second. Because that raft moving underneath her is taking away some of her velocity. When in reference to the water. Okay, so this one we can solve pretty directly. Now that you have this, you have 3 seconds, how would you go about solving this? What is the distance that she walks? Relative to the water?
Now.
Kinematic.
Ugly cat.
The distance that the lady walks, and I want you to pay attention to this because I'm still seeing homeworks that are jumping straight to, the whole kinematic. Velocity of the lady. Yeah. That's the entire kinematic. We know that there's no acceleration in the x direction.
Now her eyes are too big and she doesn't
So
like
we
that.
end up with the velocity of the lady. P. I still have people just jumping straight there. And so my question on your assignments is, how do you know that?
Do it now.
Do you realize that there's no acceleration in the x direction? Or are you just doing that because AI told you to?
I will.
You have to start from the very beginning. So then, say that delta x, that's gonna be maybe 0.91 meters per second. Seconds, that's gonna give us, she moves about 2.73 meters in the negative x direction relative to the water.
Down.
B, how far does the raft move all the way to the bottom? Okay,
Can I see?
Then you take the raft, walk through the raft, delta T.
You see who I was married to? Yeah. It's so much better. That's unfortunate. I said, which ones do I? No, just one you're married to.
Well, then we say what? Raft is moving 0.50 meters per
47
second
kids within the year.
in
Still.
1 seconds. So that's gonna give you right at about 1.5 meters. The raft moves in the positive X direction. Last part of this, how far does the center of mass of the lady raft system move in that 3 seconds? Because as she walks across that raft, that center of mass is going to shift. Because if you look at it as a single system, you start out with the lady's mass on one side of the raft, where the center of mass, if you're thinking of the center of mass as a pivot point, if you're thinking of it being balanced, that center of mass is going to be closer to her. As she moves, the center of mass will move a little more slowly, but it's going to end up, as she's at the other end of the raft, about the same distance from her that it was when she was at the other end of the raft. It's going to shift a little bit.
Library. That's fucking Zuki.
The conceptual way to look at this. Let's say we have our, let's say we have our raft, our lady. At this point, the center of mass is going to be somewhere closer to her. As she walks across the raft, we get to a point where now she's over on this side of the raft. The center of mass is now shifted towards her, where originally it was there.
I really want to know speakers, just like.
So-
It was the worst ones.
Center of mass, so we're gonna have the mass of the lady, delta X of the lady, mass of the raft, delta X of the raft, mass of the lady, mass of the raft. This is why we did parts A and B. We had to find those delta X's.
I don't like the math. Well, it's like matching. Very true. Dude, that's just so fun.
As it's
They did master and I got all the things I picked. All the good things.
If I've written this down correctly,
Like,
the delta X of the center of mass should be about negative 0.0097 meters. So not very far, but it does shift as the system changes. Okay, so we will finish this chapter on Monday. and we're gonna go on.
But the next chapter is not gonna be on the test, right?
Yeah,
She's supposed to have.
so this chapter will definitely be on the exam. What is the exam, 5, 6, and 7?
5, 6, 7, 7? 6, 7?
7.
Say it again, chapter 8.
Oh, no.
Shut up.
How many fourth graders there work today?
I don't wanna say that one.
Why would